Hey guys, it's your favourite armoured penguin again, and it's time for Common Flat Earth Misconceptions Part 2. Specifically today we'll be speaking about gravity, as gravity is a massive sticking point for flat earthers. So this is probably going to be it's going to be a longish section. Let's start with what gravity is. Simply put, is the observation that things fall. It really is that simple. Claiming that gravity doesn't exist is making the claim that nothing falls. Why things fall has been a question of philosophy since the very beginning. At first it was believed that because the Earth was the centre of the universe, everything was just attracted to this centre. So our first misconception is that gravity is a result of the spin of the Earth. I have no idea where this came from, but it's not just flat earthers who suffer with this. Quite a few people actually believe that it's the spin of the Earth that generates the Earth's gravity. Whereas in reality, the spin of the Earth actually has the opposite effect. The spin of one revolution a day reduces the amount of gravity experienced at the equator by 0.04 meters per second squared. Of course, when you compare this to 9.8 meters per second squared, this is virtually nothing, but it is there and it is measurable. Gravity is the mutual attraction of mass. This attraction is the mass of both objects over the square of the distance between them. They will both be attracted to the centre of mass between them, the barycenter. In the case of a person standing on the Earth, the mass of the Earth is 6 times 10 to the 24 kilograms, and the human would be roughly 70 or 80 kilos. The centre of the mass of these two objects is going to be incredibly close to the centre of the Earth, as the weight of the person is almost insignificant. Our next misconception is that gravity is selective. It holds the oceans to the Earth, but it doesn't act upon helium balloons, aircraft, or birds. Gravity isn't selective, and it acts upon aircraft and birds in an equal amount to water, or even cast iron. Birds and aircraft, and bats and insects and other flying animals, put a lot of effort into flying. The smaller these objects are, the less effort they need, which is why the fuel usage of a 747 is much more than the Cessna. But each of these objects puts in a lot of effort to overcome gravity. As for helium, well, if you pick up a piece of wood, it's heavy. Gravity is clearly working on it. Now push that wood underwater. You can feel it pushing back up. This is buoyancy. And it's because the wood is more dense than air but less dense than water. Now I know what you're going to say, that density and buoyancy can replace gravity. And the truth is that they can't. For the simple reason that they are both effects of gravity. No gravity, no density. Density is the mass that causes the gravity over the volume. Helium being very light for its gas pressure means that the balloon full of helium has a very low density. The air, which is much more dense, pushes down and therefore forces the helium up. This is why helium-filled balloons don't go into space. If you create a vacuum and drop your helium balloon in that vacuum, it would fall at 9.8 meters per second squared. Gravity still acts upon it. Common misconception is that gravity stops working in space. It doesn't. This is how planets orbit the Sun and the moons orbit planets. What happens when you get a spacecraft to stay in space is what we call an orbit. To put it as simply as possible, the object in orbit is falling, but it is falling forward so fast that it keeps missing the ground. Incidentally, this also explains something else that flat earthers misunderstand, and that's the gravity turns of spacecraft. Just going up gets you into space, but you'll fall straight back down again. By rolling the craft over 10 kilometers up and gradually increasing the angle of the turn until reaching the orbit's altitude, you get a more efficient way of reaching the orbital velocity. If you just aimed upwards and then upon reaching the altitude you would have to stop and turn while trying to counter the effect of gravity pulling you back down again. I will go into this more later.